Hello everyone, Mike Silverman here. In this video, I'll show you how you can share TypeScript code between different applications that you have running on different Kubernetes pods on your local development server using Skaffold. And if you change the code in your shared code library that you have, it will update on all of your Kubernetes pods that are depending upon that shared code package, and you won't have to wait a really long time for it to reinstall all the node modules and everything like that. So I'll also say that you'll probably need to know a little bit about Skaffold and about TypeScript and about Docker and Docker files and Kubernetes basics for this. And there's one important caveat that it doesn't work with create React app, so I did end up using create Next app or Next.js. So hopefully that's not a deal breaker for you. But I'll show you a demonstration of it working, and then I'll explain how I was able to achieve it. So here we have my Node server, and my Node server is running in Skaffold, and it's console logging something over and over. And it's console logging something that is from the shared code library that I've made. You can see here in the index for the Node server, I'm importing clone object from utils, and I'm outputting at an interval of every 3 seconds the result of that function. And that function lives in a shared code library that I have that is in this packages folder in my main directory for the mono repo, which is right here. And if we look there at the source at the index, we can see that the clone object takes an object and it returns clone deep of that object. Clone deep is something that Lodash made, so it's dependent on the Lodash library. And in the utils library, in the package JSON, we do have the dependency for clone deep. But you do not need to have that dependency for anything else that depends on utils. Only utils needs it. So if we look at node server package JSON, doesn't have that dependency. Okay, so we could see that obviously it's imported and it is logging it over and over. If I scroll up, you should see the scroll bar move every 3 seconds as it logs out a new log. And if we take a look over here, we could see that I have some Kubernetes pods, one for the client and one for the server. And that's where this is running. And this tab is just the Skaffold kind of like development server, I guess you could say, for a local Kubernetes cluster, so you can develop with Kubernetes on your own machine. So what would happen if I change the code in the utils package, or what I want to happen, is to see that update and for it to not take a really long time. So if I come over here and I change clone object to, instead of actually cloning the object, to just returning that string, we come back over to Skaffold, and we should see in a little bit that it will take that TypeScript, compile it to JavaScript, and then start outputting the log again, and it does. And at the same time, I have a client. So if I look at the index.ts for, this is my next client package, so I can collapse these folders here. Now we're looking at the next client. And in the index.tsx main page that it will show, we have for the h1 tag that we're going to send out the string version, because you can't put an object here, but we'll stringify that object, and we'll see that it's also using the same function, clone object, and we pass it this object. But that is imported here from our utils package, or our library that we wrote. That's the same code that the node server was using. So we're sharing code between server and the client. And if we go ahead and look at the browser, we see that we do get the result of that function. Remember, we changed it to not actually clone the object, to just be the string. But if I were to send that over there and change that again, we should see it update there as well. So let's go back over to the source. And let's take our quotes away here. And come back over. And it did update. So didn't have to refresh the page or anything. That's just the development server for Next.js, noticing that there was a difference in the JavaScript code. Because on this virtual machine, we'll get into the details a little bit later on, but it's watching the JavaScript for changes, and at the same time, it's Skaffold's copying over the TypeScript, and it is compiling that TypeScript into new JavaScript, which in turn is noticed by the Next.js development server. Alrighty. So how does it all work? Is first of all, there is something called TypeScript project references. So let me just close some things here. So let's take a look at the Node server, and we'll start with the tsconfig JSON, which is an important part of it. So in order for us to import things like how we're doing here from outside of the root directory, we have to, in our tsconfig JSON for whatever application or whatever package we're doing that import, we need to add a reference to the thing we want to import from. And the path we put here is the relative path to where this folder is. And inside that folder, we'd expect to see another project with a package JSON and a tsconfig JSON. So if we look at the utils folder, we're going to look at this tsconfig JSON, and we don't have any references here because this library, this utils, doesn't need to import anything, although it could, and you could have like a chain of them going down to more and more other code. But it's just, this is where it ends for this one. The only thing we have to write is composite true. So if composite true is here, then this can be referenced by other projects. Another thing to look at here is the package JSON for utils. So package JSON, something you would need to make sure you do here is make sure in the main option here that you put where your index.js will be once the TypeScript is compiled. So my index.js and all my TypeScript goes to the dist folder, and then index.js will just be in the top level for dist. The reason I wrote that is because in my tsconfig, I have my out directory set as dist. So when TypeScript gets compiled from here, it goes to the dist folder. And you can see I've done this locally before. And there's the index.js. So what that would allow you to do by naming the location here in the main is that when you are importing that, it knows to look in that folder for that index.js. So there's also another kind of a caveat that if you want to do nested functions, they all have to be in that index.js. So let's take a look here. If I import this subfoo, and I'll make another interval here to change it out for this one. And I'll save that. This subfoo is a nested function in the utils library. So under the source folder, we have our index.js, and we have the subfolder, and that has an index.js. And it is exporting this subfoo function that returns the string of bar. In order for us to import this from other projects, for example, our Node server or from our client, we have to export it from this index. So what I did here, as I just said, export subfoo from, and then I wrote the path to where that function was being exported originally. So you would just have to name all of your nested functions in here, which might be a little bit annoying, but It's the only way I figured out how to do it so far, but maybe you could figure out how you could not do that. That would be pretty cool. If you do, leave a comment below. Okay, but yeah, moving on. So we changed that over, and now you can see it did update here, and it's running this nested function. We were able to successfully import it. Uh, it's just showing that getting console logged. Okay, so the next kind of important thing is the Docker file and the order in which you write things in the Docker file. But before we go to that, I do have to mention one other thing that I'm using here, which is Yarn Workspace. Yarn Workspace is another way you can share code between your packages in a monorepo with TypeScript or JavaScript, but uh, it doesn't, the code sharing part of it doesn't work, or at least I didn't get able to work. I wasn't able to get it to work uh, with Skaffold and with Kubernetes. It would just constantly re-download all the node modules every time I changed something, and it would take way too long. So there's another part of Yarn Workspace that I am using, which is it lets you share node modules. And you'll see that I have this node modules folder in the root directory of the monorepo, and it has all these node modules, which is actually all the node modules for all of my packages here. So each one of these packages, they do have a node modules folder, but inside it is only symlinks, which is symbolic links, which is like a shortcut that link to this main node modules folder. The advantage of that is if, let's say, node server and the next client both depended on one of the same packages, like they both wanted to use low-clone deep, for example, I wouldn't need to have a copy of low-clone deep in each of the node modules of each of these packages. I only need to have it one time. So that saves space on my hard drive. It saves time copying. Well, I guess you never really copy the node modules. It saves time when you download it on the Docker image because you only need to download one copy of it. Like if utils and node server, both of those will be on the same Docker image, or they are in this example. And if they both use one of the same node modules, then it could be shared. So that is what the um, Yarn workspace is getting used for in this example. A little bit of a side detour, but I think it's a good feature to use and to know about. So that's why there's a package.json here in the main directory here. This just sets up the workspace and allows you to share the node modules. And this is what it looks like. It just says private true. You can set up your workspaces with specific folders, or you can say everything inside a folder, I want you to look there um, and share node modules between there. So that's what I did. I set everything in the packages folder, every folder in there, look at it as though it's uh, a project. It has its own package.json, and look at its dependencies in that package.json and share the dependencies um, in the node modules folder. Okay, so you just had to know that because that's part of the Docker file steps. So if we look over at the node server Docker file, and both of the Docker files are similar, but there's a little bit difference. We'll look at this one first. First, obviously, you choose your base image and you go to the directory that you want to host your files in. And then we're going to copy our package.json for the monorepo, and that will allow us to get those features for the Yarn workspace. That lets them share the node modules. Then we're going to make empty folders for all of our libraries and our application that we want in this Kubernetes pod. First, we make the packages folder, and you just need to make that before you make subfolders in it. It doesn't let you just like make a subfolder in a folder that doesn't exist yet. Then we'll make the empty folder for the libraries that we depend on. In this case, it's just utils. And then we will make the empty folder for the application that we're going to run in this pod. Then next, we're going to copy over the package.jsons for each of those into each of those separate folders. So we'll copy the package.json for utils. It's just going to be this file for now, and we need it for the list of dependencies here. In a moment, we'll need that. And then we'll copy the package JSON for the Node server, same deal. It's to get the list of dependencies because the next step is to install all of those dependencies. And you'll notice that we are installing from this working directory, that is the top level directory. So we don't have to go into each one of those folders and install. That's another thing to do with Yarn Workspace. If you run the Yarn install from the top level directory of the monorepo, it will go into each one of those package JSONs and it will manage the sharing of the node modules. It'll install all of the dependencies. So now we'll basically have empty folders without our code in it, but with all the dependencies in those folders. And we do want to do this first because of how the build steps are cached. Every step of the way, it caches the step so that if you were to change something at any step, like let's say we change something on this line, then everything after that line would get redone, but everything before it would not get redone. And the important thing that we don't want to redo every single time is this yarn install, because that involves downloading files over the internet, which takes really, really long time. So that's why we now copy over our code in this step. Because if we were wanting to change something in this code, we would not have to do anything before that in this Docker file. We would only do everything after it. So it would just recopy the code over and that's fine. It doesn't take a long time. Finally, after we've copied our code into their respective folders, we'll go into the working directory of the application we want to serve on this pod, and we're going to run whatever command we want to run to serve it. And what we want to do is not only serve the application, but watch the TypeScript. So let's take a look at this command here. It's in the package JSON of the main application, which in this case is the Node server. And what this does is two things. It does TSC watch, and TSC watch is a TypeScript compiler add-on dev dependency that I installed that watches TypeScript, compiles it into JavaScript. And if you add the -b flag, then it will not only watch the TypeScript for this application and recompile it, but also all of its references that were referenced in the tsconfig. And we need that because our code depends on other code that's in the shared libraries, which is why we referenced it. So you do need the -b flag. And then on success, once it's compiled, we're just going to run we're going to say node on our dist index. So whatever got outputted to the dist folder, the index.js, Node.js will run that, execute that. And every time you make a code, every time you make a change to the code, it'll recompile the TypeScript and it'll relaunch the app so you can see the changes. And it happens decently quick. Okay, so that is for Node.js applications, but also we want it to work for React front end. So if we go over to look at the client Docker file, we can see that it is mostly the same thing. And the two differences is, we're now copying Next client instead of Node server, and our command is named something else. And this command actually does something else. You could name the command anything you want. That's up to you. But what it does is in the package JSON here is this command here, serve, is going to do tsc watch -b again, but it's actually going to be happening at the same time as yarn dev. Yarn dev runs the development server for Next.js for React, and it watches changes for the JavaScript and it updates them in like a live server, like how Create React App does it too. And we use concurrently, which is an add-on here, or it's a dev dependency that lets you run two commands at once. So now every time we change something here, like, what does it look like right now? Looks like that, okay. So every time we change something, oh right, we're using this one. We could just go back to this. then this should, now it's copying the TypeScript over. Skaffold does that. Skaffold watches for the changes. Then it, on the pod itself, on that virtual machine, it sees new TypeScript. It has the TSC watch running. It sees that the TypeScript changes. It compiles it to JavaScript, and at the same time, this this dev server is running, and it sees the new JavaScript, and it says, "Okay, we'll refresh the page for you and show the changes." So that's how we're sharing the TypeScript, and that's how the Docker file is set up. Now, as far as the scaffold setup itself, we'll go into that a little bit. So we have our Docker files here, and those Docker files are going to be referenced in this scaffold YAML file. And that's going to be under the section down here, the build artifact section. And here you write the image name of the image that the YAML file in the Kubernetes section is going to look at. That's how it'll know it by this name. For example, what I mean by that, here's the node server deployment, and it's going to make containers based off of this image. Normally, it would get that from Docker Hub or whatever Docker repository you used, but since we have Skaffold, it can also look for local images, and that has to do with this local here. Right. So then we specify the exact Docker file we want. We specify the build context. The build context for me is just this root directory here. And that's why I have to say this Docker files is in the folder Docker files, because that's the context we're in. And in the sync section, we say that every time you see us change to a TypeScript or a JSON file, we want you to copy those over into the running Kubernetes pod. And that's how the TypeScript compiler that's in those pods sees the changes and makes new JavaScript. Same thing for our client, except we also want to infer and copy over TSX files and any CSS files, or whatever other files. Like if you had SVGs and such that you were changing, you would want to write that in here as well. But yeah, that's basically it. This is a problem I struggled with for quite a long time, and when I finally got it working, you know, I couldn't find anywhere else online that had exactly what I was looking for. So hopefully this is helpful and will allow you to have an easier development experience using TypeScript, sharing it amongst different packages that you may have, and developing locally with Kubernetes. So yeah, this has been Mike Silverman from the Snowden YouTube channel. Thank you for stopping by. Thanks for listening. And if you are interested in this kind of stuff, I do have a few other videos about Kubernetes and TypeScript on this channel. You can check them out. But until next time, this has been Mike. Thanks for listening. Goodbye.